Good day, sir. I am Jamda Nicole Mararo from BSMT 3 Betelgeuse. For this video, I will be discussing my CO1 assessment. So, in task 1, we have discussed the principle of ship handling, the effect of dead weight, draw, trim, speed, and underkill clearance by illustration the complete parts of turning circle of MB Crystal E with the right-handed propeller in normal full loaded condition with maximum rudder angle fall ahead RPM. So this is my task 1, sir. We have the tactical diameter, 90-degree change of heading. We have transfer, our turning radius 180 degree change of heading. We have drift angle, advance, rudder execute, approach, course. So this is turning to the port with maximum rudder angle fall ahead RPM. And for our turning to starboard side with maximum rudder angle fall ahead RPM. So we have tactical diameter, our distance transfer, 90-degree change of heading. We have 180-degree change of heading. For our turning radius, fourth of midship point, we have our drift angle and our advance. For our task number 1.2, we have to discuss by comparing the difference of its turning circle parts between when turning to port side and turning to starboard side, and ballast condition and full loaded condition. So this is our ballast condition, full C, speed 104 RPM. For our transfer diameter, we have 0.58 nautical miles. For our transfer diameter, we have 0.581 nautical miles. For our advance, we have 0.488 nautical miles. And advance 0.486 nautical miles. We have our 16.9 knots, 1 minute 24 seconds, 12.8 knots, 3 minutes and 23 seconds, and 11.1 knots and 5 minutes 08 seconds. And for our advance 0.486 nautical miles, we have 16.8 knots, 1 minute 43 seconds, 13.4 knots, 3 minutes 24 seconds, 12.8 knots and 5 minutes 10 seconds. So our port is 26.1 knots. For our starboard is 26.1 knots. So the port side is the side of the vessel which is to the left of an observer on board the vessel, and the facing of the bow, it is facing forward towards the direction the vessel is heading when underway, and starboard side is to the right of observer. For our full loaded condition, full C, speed 104 RPM, we have transfer diameter 0.1111 nautical miles. Transfer diameter, we have 0.54 nautical miles. For our advance, we have 0.388 nautical miles. We have 16.9 knots, 2 minutes 06 seconds, 11.5 knots, we have 4 minutes 10 seconds, 9.7 knots, we have 6 minutes 14 seconds. For our advanced 0.373 nautical miles, we have 70 knots. 2 minutes 07 seconds, 12.2 knots. We have 4 minutes 11 seconds. We have 11.34 knots. And 6 minutes 24 seconds. So the difference between the ballast condition is it will be faster and easier to turn than on full loaded condition because it will be heavier. For our task 2, we have, based on the illustration, discuss your action with the effect of wind and current on the ship handling while maintaining safety of navigation. So the appropriate action for the illustration is to anticipate and understand the countermeasure according to the wind and current affecting the ship course. Avoid any turnings to port side to avoid hitting the coast, and should reduce the speed to have more time in performing action for safety procedure. Apart from that, the effect of current and wind must also be considered while handling the ship. Navigational officer should be take into account different current stream that can exist over a small area within which the vessel has to maneuver. For our task 3, we have explained why human factor is one of the other variable factor affecting ship handling. So, human factor, a delay in the time between your given order and the execution of the order will affect how you intend to move your ship. This is caused by human factor because the individual you are ordering may have different response depending on their training and ability to perform the job, or that the orders have to be relayed by an officer to the helmsman, which is bad practice that should be avoided, so that the coming officer should be able to give his order directly to the helmsman. That explains why human factor is one of the other variable factor affecting ship handling. So for our task 4, discuss squat by answering below. I 5 question about squat effect. So we have question number 1, why and how squat effect take place. Squat is the decrease in ship under keep clearance when it moves in shallow water because of low pressure created under the ship. When a ship moves forward, it pushes the water forward. The water all around must flow under and around the hull to replace the volume of water pushed by the bow. Now, as the pressure at the bottom of the ship decreases, ship need to react in some manner to compensate. Ship is zero. This drop in pressure is compensated by sinkage of the vessel as the direction of this force. Question number 2, we have what are the factors that affect squat? Speed of vessel. This is because with more speed, the vessel will push more water forward and more water is required to fill that void. This will cause more drop in pressure under the hull and vessel need to sink, move to compensate for that drop in pressure. Block coefficient of the vessel. A box-shaped vessel will push more water and hence will have more squat. So, more the block coefficient of the vessel, more will be squat. Question number 3. How do we know if the squat will result in forward trim, an aft trim, or no trim. With full form shape will form shape like super tanker. It is other way around. On this shape, bow shape is what we called fall form, because of which bow obstruct considerable amount of the water flow. The resultant low pressure created by the obstruction is forward of the midship, and this vessel squat will occur more at the bow. This will result in trimming forward because of the squat and the vessel. The tendency of the bow to obstruct the water flow is related to the block coefficient of the vessel. Block coefficient of the vessel also defined if the vessel will squat bodily by stern or by bow. Question number 4. What are the signs that show vessel is experiencing squat? Number 1, we have ship steering become sluggish. That is, it become comparatively difficult to steer the ship. Number 2, engine RPM will decrease to compensate for the load on the engine. Number 3, the speed of the ship will decrease. Number 4, we have the ship may start to vibrate. Number 5, mud showing up around ship hull. Number 6, vessels rolling and pitching reduce. Number 7, turning diameter of vessel increases. That's all, sir.